All right, let's take a look at section 7.3. So a little math humor here. I can't believe schools are still teaching kids about the null hypothesis. I remember reading a big study that conclusively disproved it years ago. Ha ha. 7.3 is going to work the same way as 7.2. However, we will not have sigma. We won't have the population standard deviation. So just like in chapter 6, we have to change. If we only have the sample standard deviation, then we're going to have to use t-stat instead of z-stat. We're still going to have the level of significance alpha, just like we did. We do need degrees of freedom. This, just like we had in chapter 6. Remember, degrees of freedom is just sample size minus 1. But otherwise, all of the hypothesis testing is going to work the same way. We're going to have a left tail test, a right tail test, two-tailed tests. We're going to have p-value. We're going to have rejection regions. All of that's going to work the same. We're just going to use t-stat because we're in a t distribution. And that's all because we do not know the population standard deviation. All right, let's do a quick review. We know that a left-tailed test is when our alternative hypothesis has a less than sign, so it's pointing to the left. The right-tailed is the opposite. It's if I have a greater than sign, so pointing to the right. And then finally, a two-tailed test is if my alternative hypothesis is not equal to. We do have to be careful depending on which test we're doing of whether we have to split up the alpha into each tail. Now, we do not worry about degrees of freedom in StatCrunch unless it literally asks for degrees of freedom. If it asks for sample size, you just put in the sample size. Don't adjust it by subtracting 1. Now, if they ask me for the critical value, T naught, for a left tail test with alpha equal to 5%, 0.05, and n equals 21. All right, so I have a left tail test. I know that my area is to the left here. I want that area to be 0.05. Because they're asking for t, I know that I'm going to have to go to calculator T in StatCrunch. The first thing it's going to ask for is degrees of freedom. And then it's going to ask me to fill in the rest here. All right. Degrees of freedom, since my sample size is 21, I want to go one less. So degrees of freedom is 20. Because it's a left tail, I want a less than or equal to here. I don't know the score on the number line. That's what I'm looking for, but I do know my area. My area is 0.05. Remember, that's always going to be on the right-hand side. At that point, I'm going to hit compute, and it's going to give me the t-score inside here, and that is negative 1.72. I'm going to show you what it looks like in StatCrunch on the next slide. All right, so I went into calculators. I went all the way down to T. I don't want between this time because I'm looking at a left tail test. So I want the area and the left tail. So I put in my degrees of freedom of 20. I put in a less than sign. I put in the 0.05 on this side for the area. And then StatCrunch is going to give me negative 1.72. And so that is the t-score that we are looking for. All right, so this one's the same idea. It's just that we want a right tail. Since we want a right tail, we are going to have a greater than or equal to sign inside calculator T. Our area of 1% is going to go on the right-hand side. Our degrees of freedom is 16 because our sample size was 17. and then the computer's going to do that work for me and tell me that my critical value is 2.58. All right, one more with the critical value. So we have a couple choices. We could do StatCrunch twice and hit each of the ends. That's probably the easiest way to do it. But if we do that, we have to remember, because this is a two-tailed test, we have to take the alpha of 10% and divide it by 2, because the alpha is 10%. That means that I have to put 5% in each end. So it would be 0.05 on this side and 0.05 on this side. So now when I go into calculator T, when I do the left-hand side, I'm going to go ahead and put my degrees of freedom, which is 26 minus 1. So that goes here. I'm going to put my 0.05 here, my less than sign here, and I'm going to get negative 1.71. Then I could do it again and do greater than if I want, or I know that because of symmetry that the other score that I'm looking for is going to be positive 1.71. Now the other way you could do it is do a between. The problem is if you do between, you're going to get this area in the middle. And so we would have to actually use 90%, not 10%. You'd have to take 1 minus or 100% minus. Okay, so just like we did in chapter 6, we have our t-test. We can find t by taking the sample mean minus the population mean over the adjusted standard deviation, but it's the sample standard deviation. That's when we're going to use t-test. We still have that the population has to be normally distributed or greater than or equal to 30 for the sample size, and then we have degrees of freedom is n minus 1. So what we have to watch for is if we have sigma, if we have the population standard deviation, then we're going to use z-stat and we're going to use calculator normal. If we have S, which is the sample standard deviation, then we're going to use t-stat, or if we need a calculator, oops, I can't, I'm having trouble here. If I need a calculator, I'll put it over here. I'm going to use calculator T. All right, let's try a problem. So we have a used car dealer who says that the mean price of used cars sold in the last 12 months is at least $21,000. Okay, so at least 21,000. That means that we are going all right, sorry about that. And so for what the car dealership said, we've got mean greater than or equal to 21,000. All right, that's the null hypothesis. The alternative hypothesis is that the mean is less than 21,000. And that's our claim because we suspect that the car dealership is wrong. So then we're going to grab all of our data. We have a sample size of 14. We have a mean of 19,189. We have a sample standard deviation. So since we have a sample standard deviation of 2,950, we have to use t-stat. And then also we know that we have a left tail test, and that's because of our alternative. So we're going to go ahead and put all of that into t-stat, just like we did for z-stat. At that point, we're going to hit compute, and we'll get a p-value. So our p-value is 0.0195. That is less than our alpha, which is 0.05. And so we're going to reject the null hypothesis? Well, since we rejected the null hypothesis, which is what the car dealership said, then we can support the claim that we think they're wrong. Okay, so since we rejected H naught, which is what the dealership said, we can support our claim. Our claim is that we thought they were wrong in the first place. All right, this page just shows you how I used it. So I went into t-stat, one sample with summary. I put in all my information. I put my hypothesis test in, hit compute, and it gave me my p-value, and I was able to compare that p-value with alpha. Now, if they had asked me a little different way, if they had asked me to look at the rejection region, that's what I did here. So I had to find my critical value here on the graph, which I did with the negative 1.771. I did that by going to calculator T, and then the t-stat gave me my test statistic of negative 2.297. And you notice it's sitting here in the rejection region. We already knew that we rejected H naught, but this is just another way of looking at it. So you can look at it as the p-value, or you can look at it as the test statistic. All right, let's set up one more together. So an industrial company claims that the mean pH level of the water in a nearby river is 6.8. Okay, so the company claims that the mean pH level is 6.8. So I put that right here. That's my null hypothesis. Then it says you randomly select 39 water samples and measure each. Okay, so my alternative is going to be the not equal to, right? The claim is the null hypothesis. I'm going to grab all the information I have. They gave me the sample size of 39 water samples, the mean of 6.7, the standard deviation, but it's the sample standard deviation. Notice it doesn't say population anywhere. So as soon as I see that it's the sample standard deviation, I know that I'm going to have to use t-stat. And then finally, they gave me my alpha of 5%. So I'm going to go into t-stat, put everything I know into t-stat, and hit compute, and it's going to give me my p-value. Well, my p-value is 0.0824. That is greater than my alpha, my level of significance, of 0.05. Therefore, I am going to fail to reject the null hypothesis. Okay, so I failed to reject the null hypothesis. Well, the null hypothesis was the claim. So if I didn't reject it, then I must support it. All right, I know that wording is a little tricky. Getting all the numbers is the easy part. It's getting to the bottom. But since I did not reject the null hypothesis, which was also the claim, then I actually, in reality, supported that claim. If I had rejected the null hypothesis, then I would have also rejected the claim. I could not support my claim.